Dear learners, greetings of the day. This is Indrajit Varad Pandey presenting before you the discussion about basics of differential equation. As you all know that mathematics is a branch of science which deals with numbers, arithmetic, functions, and as we move to the higher classes we are mostly concerned about the functions. So calculus is the major part of the mathematics which is required for the higher level education. So what is actually the calculus? As in a broader aspect, if we see calculus, it contains derivative and integration, because derivative and integration are playing a major role for most of the conceptual things in the subject mathematics. So in this particular video we will be discussing about the basics of differential equation. The contents of the video are: first is introduction to the differential equations, then who invented, how it was invented, or how the idea came for invention of the differential equation, the basic thing about the differential equation, that is order and degree of differential equation. Then we actually move towards the formation of differential equation. Then what are the methods, how the differential equations are solved. The most familiar method is variable separable method. And lastly, what is the necessity, why do we need to study the differential equations. So that last part will comprise of the real-time applications of differential equation. So what do you mean by differential equation? Just now what I said is calculus. Calculus is the branch of mathematics which is or I can say the science which is related to the rate of change, and which was invented by Sir Isaac Newton in the process of investigation of some natural phenomena. So many other types of systems can be modeled by writing down an equation for the rate of change of phenomena. See, when we move from one place to other place, we call it as a rate of change of displacement. As you all know that you are moving from one place to other place. Right now you are moving from your home to your friend's house, so there is a change in the place, so you have been displaced from one position to the other position. So therefore wherever such kind of phenomena comes into the picture, we calculate or we try to include or we try to find out the rate of change, and that is what calculus is all dealing about. So may it be derivative, may it be integration. What does integration do? Integration goes on adding or increasing the function. What does derivative do? Derivative keeps on decreasing or reducing the function. So in general, this calculus will nothing but be the science which deals with the rate of change. So what are those practical applications wherein I can find out the rate of change? The first one is bandwidth utilization in TCP networks. Mostly electronics and telecommunication people or electrical engineering people will be dealing with it. Acceleration of a car, motion of a car from one place to the other place. Secondly, population increase. It is always an increasing function. So accordingly, I can calculate. Chemical change of some kind. Decay of a material by radiation of alpha particle or beta particle. Locus of a football. When a football is kicked, a projectile motion is measured, and that is how we calculate the locus with the rate of change of position of a football from one place to the other. So all of the above behavior can be captured by very simple differential equations. Now what does the basic definition tells about the differential equation? A mathematical equation that relates a function and its derivative is called a differential equation. If you split the word differential equation, it is containing two words. If you separate this particular phrase, one of them is equation. In mathematics, what is an equation? An equation is that particular expression which contains equal to sign, and other I am saying the differential word. What does the differential word refers to? Differential word refers to differential coefficient, or in general calculation of a derivative of one variable with respect to the other variable. So in general, if y is a function of x, so I say that its derivative with respect to x is written as dy by dx. So in such case, I call y as a dependent variable and x as an independent variable. Similarly, if what is the example of this kind of function? Y is equal to x square. If you change different values of x, you get different values of y. So therefore, y is dependent on x. So therefore differentiation of y with respect to x will be called as dy by dx. In turn, or on the contrary, if I take x as a function of y, suppose x is equal to y cube is a function which is defined. So in that case, I will have x as a dependent variable, y as an independent variable, and hence the derivative will be written as dx by dy. So likewise, such equation which contains a function or a dependent variable, independent variable, and the derivative is called as differential equation. What is the logic behind it? Function usually represent physical quantities, derivatives represents rate of change, and hence a differential equation will be termed as that relationship which interrelate or which correlates between the two. Between the two means a function which is containing physical quantity and the other one which defines the rate of change. What is the origin, how these were invented or discovered? History of differential equation is, if you see back, it was invented by Sir Isaac Newton and the German mathematician Leibniz. So we can have the proof of the article, the history of differential equations, which was defined between 1670 to 1950, and these are the legends who invented or have major contributions in the calculus. Either you say the differentiation or you say the differential equations. Now everybody is familiar with the performance of the practicals. When you perform any practical in the physics or chemistry, mostly the mechanical concepts what we talk about, we have to verify or validate our results from the theoretical value and the observation value. From the observation value, what you do, you take the set of observations and try to plot it on the graph paper. In that case, how to validate with minimum errors is you calculate the slope. What does slope says? Slope says change in value of y with respect to change in value of x. So whatever is the difference between the two, that ratio is nothing but the slope. But if you shrink them or if you treat the change as infinitesimally small, you can easily convert it into the term delta y or delta x. So that much change in the value is nothing but delta x. That change in the value with respect to variable y will be delta y, and ratio of this delta y upon delta x will nothing but be slope, which is obviously the change in value of y with respect to change in value of x, and in general we call it as a dy by dx. So mathematically, if I have to write the definition of a differential equation, it is an equation with a function and one or more of its derivative. Maybe you have a differential equation with the derivative of y with respect to x or with the derivative of x with respect to y. So here if you can see, we have an equation because equal to sign is there. We have a variable y which is a function of x and its differential coefficient or derivative which is called as dy by dx. Rest all quantities, say independent variable or constants, anything can be there. So how we identify the differential equation format? The first one what you see is a differential equation because it contains derivative and it is also containing equal to sign. Another notation for the derivative is double dash represents second order derivative, single dash represents first order derivative. So first one and second equation are the best examples for the for noting the or denoting the differential equation. Third equation, if you see, it is not the standard form because it contains the inverse function. It does not contain the derivative. And last one itself is not an equation because it is not containing equal to sign. Now, the major portion is how to form, because solving of a differential equation is of our interest as we are dealing with the applied mathematics portion. But unless and until differential equation is formed, we cannot solve it, right? So accordingly, when we have to form the differential equation, how it is generated, whatever is the function defined, we have to differentiate it accordingly. So if you see, this is a very familiar equation of a straight line which passes through origin. Y is equal to mx is the equation of a line which passes through origin. If I have to form the differential equation, surely it should contain the differential coefficient. Containing differential coefficient means I have to differentiate it. So considering the equation y is equal to mx, I am differentiating with respect to x both sides. So I get on the LHS dy by dx and other equation, other RHS as y. So other side of the equation will not contain x because it is not containing the variable, because derivative of x with respect to x is 1. So in general I am getting dy by dx is equal to m accordingly. But from this particular equation I know y is equal to mx. So what is m equal to? Y by x. So I substitute the value of m as y by x. So dy by dx becomes equal to y by x. Multiply this x on the other side, you get x dy by dx equal to y, which is a differential equation of first order. Now we will be mostly dealing with the definition of order and degree, how we identify whether it is first order or second order. Take another example. This is a family of curves which is represented by y is equal to a cos of x plus b. How many constants are there? A as well as b. In the earlier equation, if you see, only one constant was there, m, and we have tried to eliminate it. Here we will be trying to eliminate a as well as b. So once I differentiate dy by dx, you get derivative of cosine is minus sine. Accordingly, this will be 1. Again you differentiate, you get this value, replace this value by y because that is your original function, and accordingly we get the differential equation as d2y by dx square plus y equal to 0. Original equation was containing a cos of x plus by. If you see, original equation contains y is equal to a cos of x plus b. I differentiated, you get minus sine. Again you differentiate, derivative of sine becomes cos. This is your original question, and accordingly you get the value as d2y by dx square equal to minus y, and hence the differential equation formed is d2y by dx square plus y equal to 0. This differential equation is of order 2. Similarly, by eliminating 3 arbitrary constants, your differential equation will be of third order. Similarly, in general, if I have n arbitrary constants, the differential equation generated will be of nth order. Now what I was talking about is order and degree of the differential equation. What does order mean? Order means highest derivative present in an equation is nothing but the order of the differential equation. In this particular differential equation, you see one of the differential coefficient is dy by dx, other differential coefficient is d2y by dx square. Highest of both is d2y by dx square because it is differentiated twice and we obtained it in that manner. So order of this complete differential equation will be the order 2 because it is the highest derivative which is present. In this example, dy by dx plus y square equal to 5x, only first order derivative is there, therefore I call it as a differential equation of order 1. Take another example. This is d2y by dx square plus xy is equal to sin x, and accordingly its order is nothing but 2. Here out of the 2, highest order is d3y by dx cube, third order derivative, so order is 3. Now degree, how you calculate the degree? Degree is the integral power or exponent of the highest derivative which is present. Now in the first example, it is dy by dx whole square plus y is equal to 5x square. dy by dx is first order derivative, so order of the differential equation will be 1. Uska power, the exponent or the integral power of this particular ordered derivative is 2, so I will be considering it as degree 2. So it is a first order second degree ordinary differential equation. Similarly, in this particular example, highest derivative is d3y by dx cube, means what is the order of the differential equation? 3. What is the integral power of this differential coefficient? Nothing is there. Nothing is there means power 1. So I call it as third order first degree order differential equation. Do not get confused. If you see that यहाँ पर तो दिख रहा है dy by dx whole square, so dy by dx is first order derivative though its integral power is 2, but I won't be considering the power of the lower order derivative. I will be considering the power for calculating the degree for the highest ordered derivative. Whatever is the highest order of the derivative present in an equation, you will be concerned about its integral power. That will be termed as a degree of differential equation. So now this was all regarding the formation of differential equation. Now how you solve the differential equation. Right now I clearly said that formation of differential equation is nothing but differentiating it by eliminating the arbitrary constants. Now reverse process will be for obtaining the solution of the differential equation. So what will be the solution? Solution will be containing only the variables like say dependent variable, independent variable and some arbitrary constants, but it will not contain any of the differential coefficient in the solution of the differential equation. The solution of a differential equation is a relation between variables not taking the differential coefficients, satisfying the given differential equation and containing as many arbitrary constant as its order. Now here comes into the concept that if you have two arbitrary constants in a equation, you will be differentiating it twice, so you have the second order derivative and hence second order differential equation is formed. Means number of arbitrary constants present in the solution will be related directly to the order of the differential equation. If you see here reverse, I formed the differential equation by twice differentiation. So in general I got the, or at the end I got the second order differential equation. If I have to get back the solution of it, I will have to twice integrate so that I get the arbitrary constant. As you all know, in case of indefinite integration, after integration we add the arbitrary constant c. Usually we take it as c. Likewise here also we integrate it twice, that means you need to have two arbitrary constants. So accordingly in general solution will contain the arbitrary constants. So there are two different kinds of solution. One of them is a general solution, another one is a particular solution. Now how we distinguish or differentiate between the two, that which one is a general solution and which one is the particular solution? General solution will contain arbitrary constants only. Now what do you mean by arbitrary constants? Arbitrary constant means which may take any value. Right now we don't know its value, therefore we are denoting it by say a, b or in general c, or many times we use it as k. But when I talk about the particular solution, it will be surely calculated specifically or particularly. Its value will never change later on. Arbitrary constant may take different value as per the solution or as per the equation. So general solution is nothing but the solution which contains the arbitrary constants. So y is equal to a cos x minus b sin x will nothing but be the solution of the second order differential equation because it contains the arbitrary constants a as well as b. If you have y is equal to minus b sin x, how many arbitrary constants are present? Only one arbitrary constant is present, which cannot be the solution. Why? Because here the differential equation is of order 2. So this differential equation its solution should contain two arbitrary constants in it. Now what do you mean by particular solution? Giving particular values to the arbitrary constants. Now at random I cannot pick any of the value and assign it to the arbitrary constant. With some initial condition or imposing certain conditions, we can easily evaluate the value of these arbitrary constants. So here the same equation or same solution, when I write it as y is equal to 3 sin x minus 2 cos x, you observe minutely in the previous slide a and b are now replaced by 3 and 2. So they are taking a particular value. 3 will never change anywhere you go in the world. 2 will never change. But yes, in general solution a and b can change if you impose different condition. So in this case it will be called as a particular solution of the differential equation d2y by dx square plus y equal to 0. So this is how we talked about the formation of differential equation and solution of differential equation. Now how to obtain the solution of differential equation? The most familiar and usual method is variable separable. Now as the name suggests, variable separable means I have to separate the respective variables. In the differential coefficient dy by dx, dy is one of the differential, dx is one of the differential. What is my job? My job is to attach the variable y with the differential dy to attach the variable x with the differential dx. So how you write down the first order differential equation? Simply it is dy by dx is equal to function of xy is called variable separable provided it is written in the form of product of function of x as well as function of y. Suppose we write this particular above equation as dy by dx is equal to function of x into function of y. So g of x into h of y. So we have separated the variable. Initial function is splitted into the product of two functions, that is function of x multiplied by function of y. Now by taking function of y, that is h of y, to the LHS, the equation becomes 1 upon h of y into dy and g of x into dx. If you see the previous slide, it was g of x on the right hand side, differential was on the left hand side, dy by dx. I tried to move dx on the other side and h of y on the other side. So this becomes 1 upon h of y into dy and g of x into dx. Now what is my job? I have to remove the differential. Just now I said to remove the differential you have to take antiderivative. Antiderivative means it will be integration. So integrating both sides, one side becomes integration with respect to y independently, other side becomes independently integration with respect to x, and as it is a case of indefinite integration, I will be adding the arbitrary constant c. So where c is the arbitrary constant. So variable separable, the best example is dy by dx is equal to 5xy. Derivative is dy by dx. I have RHS as a product of two functions. 5 you can keep anywhere, no issue in that. So what are the possibilities? Y to be shifted on this side and dx to be shifted on the other side. So this is how I have separated the given question by variable separable method, and the rest process is same, integrate. In this automatically the question of integration is solved, because here on the left hand side whatever is the term, it is function of y with the differential dy, it is function of x with the differential x. So accordingly integration is possible. Now lastly, what are those applications of differential equations? In the initial slide about the contents of the presentation, I talked about the real-time application. So Sir Isaac Newton in chemistry also had given the best law, which is called as Newton's law of cooling. It is used to determine the temperature. It is used to determine the rate of change in temperature. When a person is dead, if you have to calculate that how many hours before the person expired, accordingly from the present temperature and the room temperature or his body temperature, I can easily calculate. So that is what is a Newton's law of cooling, and which is in the form of a differential equation. So this law states that rate of change of temperature of an object is proportional to the difference between its own temperature and the temperature of the surrounding. Where do we find the applications of Newton's law of cooling? It is it is used for the purpose of investigation to determine the time of death. For computer manufacturing, that is processors and cooling systems, we are now using so many equipments, cooling gadgets like AC and all. So all that cooling effect depends on the Newton's law of cooling. Solar water heater is again on the extreme end. It is the best example. Calculating the surface area of an object, it is one of the application of the differential equation. In physics or mechanics, if you come across simple harmonic motion, is nothing but the best example, wherein it states that restoring force is directly proportional to the displacement of the spring. So I have given one example with the help of the spring, how it is compressed, and we can easily find out the relation between the compression of the spring and derive a differential equation to study its characteristics. So mostly we try to deal with the basics of differential equation. What does differential equation mean? How they were invented? What are the terminologies related to differential equation, like say order or degree of the differential equation? How to solve the differential equation? And before that we should know how the differential equation is formed. So accordingly, in the last we saw about the applications of differential equation. Thank you for patient listening. Hope there is some add on in your knowledge. Thank you.